Ask nothing. Ask nothing. Want nothing in return. Want nothing in return. Give what you have to give. Give what you have to give. It will come back to you. It will come back to you. But do not think that now. But do not think that now by Swami Vivekananda. Hi everyone, this is Akshay, Faculty of Mathematics, Vivek Vidya Youth Forum, New Delhi. In this particular video lecture, we will be dealing with example numericals belonging to Unit 2 of the chapter Real Numbers. Let's begin with our first example for the day. Consider the number 4n, 4 to the power of n, when n is a natural number. Check whether any values of n for which 4 to the power of n ends with a digit 0. If a number 4 to the power of n for any n where the n the digit should be 0, then it would be divisible by 5. So the prime factorization of 4 to the power of n would contain a prime factor 5. It should be divisible by 5 first thing. So the prime factor contains a prime 5. This is not possible when 4 to the power of n can be written as 2 into 2 to the power of n. So that only prime factorization of 4 to the power of n is 2. So the uniqueness of the fundamental theorem of arithmetic guarantees that there is no other prime factors for 4 to the power of n. So there is no natural number for n, natural number n for which 4 to the power of n ends with the digit 0. So look at this, how nicely, how beautifully they have explained why 4 to the power, why there is no natural number for n for which 4 to the power of n ends with digit with a 0. So if you have already learned to find HCF and LCM of positive integers, yeah, we have already learned by using fundamental theorem of arithmetic in earlier classes. Without realizing it, this method is also called as prime factorization method. So only I told the names might be different, but the concept remains same. It is known as prime factorization method. This same prime factorization method, we will be using it in quadratic equation, known as factorization method using splitting the middle term. Splitting the middle term using factorization method, the same concept, same thing we will be using over there, but the name over there is different. Concept remains same. Let's recall this method in this example. Okay. Let's see what is that method we will be recalling. So LCM and HCF of 60 and 20 using prime factorization method. Sorry, not 60, it is 6 and 20. 6 can be written as 2 into 3. 2 and 3 both are prime factors, so this is done. 20 can be written as 2 into 5. Okay, 2 square into 5 to the power of 1. You can see it's a power of a prime number itself. It's a power of the prime number itself. You can find the HCF of 6 and 20 is 2. And LCM of 6 and 20 is 2 into 2 into 3 into 5. Which is 60. Which is 60. So this LCM and HCF we have already learned how to find in the previous years in our lower grades. So just we are recollecting it. We are recollecting how we have solved it. That's it. Now HCF of 60 and 20 is 2 to the power of 1. So product of the smaller power of each common prime factor is the number. LCM is 2 to the power of 2, 3 to the power of 1, 5 to the power of 1. The product of the greatest power of each prime factor involved in the number. The product of greatest power of each prime factor involved in the numbers. From the example, we can learn about LCM and HCF. The product of both LCM and HCF is nothing but equal to the product of the factors itself, A and B, whatever, 6 and 20. Product of 6 and 20 will be equal to product of LCM and HCF, which we have got. So you can verify it back again. Right? Yes. Next question, find the HCF of 96 and 404 by prime factorization method. 96 and 404 by a prime factorization method, and hence find the LCM. So prime factorization method for 96 and 404 gives us 96 can be written as 2 to the power of 5 into 3. 404 can be written as 2 to the power of 2 into 101. 101. Oh, 101, right? Yeah, 101 is a prime number. So 101 into 2 to the power of 2. Therefore, the HCF will be 2 to the power of 2, which is equal to 4. And then LCM will be 96 into 404 divided by HCF. What is the HCF? 2 square. That is nothing but 4. Later, you get it over here. I will simplify. 4 1 times 4 101 times. Sorry. 4 101 times 96 into 101 is nothing but 9696. So this is the LCM. Pretty simple. Example numericals are simple, means exercise questions will also be simple. I can only assure you so much. Exercise questions will also be simple, and it's not a child's play actually. It's not a child's play, but it's not so difficult as people suffer. Like mathematics is difficult. Mathematics is never difficult. It's the game played with 10 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Only these 10 digits we will be playing around in our mathematics. That's it. Okay. Find the LCM and HCF of 672 and 120 using prime factorization method. Usually prime factorization method, they do not specify it, but rather they say it as using fundamental principle or what's it called? Just a minute, wait. Fundamental theorem of arithmetic. Using fundamental theorem of arithmetic, find the LCM and HCF, they will ask. But people go on to a stuck over there. What is fundamental theorem of arithmetic? They will forget it off completely. They would have forgot what is fundamental theorem of arithmetic, but rather they remember what is prime factorization. But I say prime factorization, wherever it is given in your textbook also. Right here. Next to it, write it. Fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Right. Yes. So we know 6 can be written as 2 to the power of 1 and 3 to the power of 1. They have not written powers, it's understood. And 72 can be written as 2 cube into 3 square. 120, 2 cube into 3 into 5. So the smallest power of the common factors, 2 and 3 itself respectively. So yeah. Henceforth, the HCF is nothing but 2 into 3, which is 6. And the LCM will be 2 cube into 3 square into 5, which is nothing but 360. You can again find out over here. What you find out over here is 6 into 72 into 120 is not equal to the product of HCF and LCM. Why? Why it is not equal to the product of HCF and LCM? I say the rule which I told, product of HCF and LCM is equal to the product of A and B. So that is only applicable if there are only two terms over there. A and B, product HCF of A and B into LCM of A and B will be equal to product of A and B. But here there are three terms, three numbers. So it won't work out over here. Clear with this? If this is clear, let me just say what all we learned. We learned that fundamental theorem of arithmetic is nothing but prime factorization method of finding HCF and LCM. That's it. As a whole, as in a nutshell, we learned only so much in this concept, and we will see you in the next video. Thank you. Thank you. Thank you. If you have liked this video, please click on the thumbs up button. Do share this video. Please post your doubts in the comment window. We'll see you soon and we'll respond to your comments. Thank you.